Algebra, we are kicking off Unit 2 with a little bit of rational number comparison. We'll be focusing on integers, decimals, and fractions. But first, I want to review kind of what these symbols mean. What does this symbol, first one in the table here, what does that mean? Is it, I'll give you a hint, it's either less than or greater than. Less than. Sir, how do you remember the difference?
Because if the arrow's pointing that way, it's less, and if the arrow's pointing that way, it's greater.
Okay, so YouTube can't see which direction that you pointed, but yeah, if it's pointing to the left, it's less than. If it's pointing to the right, it's greater than. Any other ways, any other tricks that people have? Yeah?
I'm confused because my first grade teacher always said that like the open side was like, even no matter what way it was, it would always be the greater number.
Yes. So your first grade teacher was not incorrect. What she said was that no matter which way it's pointing, the open side is to the greater value, right? So if we're comparing like 2 and 5, okay, would you agree that 2 is less than 5?
Yeah.
Right? 2 is less than 5? Mm-hmm. Okay? And we have the open side toward that greater value, right? If I reverse this, if I put the 5 first, 5 is greater than 2. Would you agree with that? And our open side is still facing the greater value. Okay? But as far as, so that rule holds here, okay? But as far as what that symbol, that first symbol is called, it is the less than symbol. When you see that symbol, whatever values on the left side of it is less than the values on the right side of it. Okay? And then for greater than, the value on the left side is greater than whatever value is on the right. Okay? Any other tricks? We have this which way it's pointing, which way it's opening, anything else? No? For me, growing up, I always thought like the less than symbol is kind of like if you kind of squeeze that L together, you get something kind of like that, or you kind of turn it. So that's how I remember that was the less than symbol. It does look kind of like an L. Okay? And the other one is the greater than symbol. Okay? And then of course we have the equal to symbol, right? And all three of these are used to compare. When we compare values, is one less than another, greater than another, or equal to another? Those are basically your three options, right? Less than, greater than, equal to. Okay? So far so good? Mm-hmm. All right. So we're gonna begin with integers, and we talked about integers last unit. An integer, remember, is a positive or negative non-decimal value. And if you struggle with this, with integers, I recommend using a number line. Okay? Using a number line. Well, let's use one below our first one. -7 and -10. What symbol would you put in between there? Is -7 less than, greater than, or equal to -10, Ava?
It's greater than.
It's greater than. And how do you know that?
Because on a number line, 7 is closer to 0 than 10 is.
Yeah, right. So if you make a number line, and here's 0, it's a pretty good circle. And we mark where -7 is, okay? And then we mark where -10 is. Since -7 is further to the right on the number line, it's going to be greater than -10. Okay? Because as you go to the right, values get bigger. As you go to the left, values get smaller. How about -4 and +2? What symbol's going in between there? Dominic? Less than. Any negative number will always be less than a positive number. Right? It's on the other side of 0. Let's hop down to one at the bottom there. -16 and -13. -16, -13. What symbol is going in between? Think of that number line. Which one is on the left and the right? Kind of picture where they are. Think temperature. Which one's colder? That's going to be the lesser value. Madeline?
Less than.
Less than. -16 is less than -13. It's further to the left on the number line. Okay? It's the colder temperature. It all kind of fits in, right? So you've got a section there just comparing two of them. Okay? And then below that, it says order the integers from least to greatest, least to greatest. And again, if you want to use that number line, just kind of plot them all on here, that'd be kind of helpful, okay? We kind of look at our values, which one's going to be first? Which one's furthest to the left here? Layla? -8. All right, that's our coldest temp, furthest to the left. Which one's coming next?
What? Oh,
After -8, which one is the next value? Liv?
-6.
-6, good. Okay, estimate that be right about there, and then what? Madison?
-3.
-3. Okay, and then we have that 0 there. We know that's, neutral, okay? On the left side of 0 are all the negatives, on the right side of 0 are all the positives. And so what comes next? Sawyer? 5, and then what's left? 7. So if you put them all on a line like that, you can kind of see, you can track it from left to right, -8, -6, -3, 0, 5, 7. It all kind of falls in a line, okay? That's why it's called a number line. Questions on those? Didn't expect to spend too much time on integers, but it's just worth bringing up. Okay. Next up is decimals. Comparing and ordering decimals. What's your strat for that? Comparing and ordering decimals. Melanie?
I always look at the number in the tens place.
Sure. Okay. Look at that number in the tens place. If they're different, you don't need to care about anything else. Right? 0.223 and 0.793, if we just look at that number in the tens place, that tells us everything we need to know. What symbol's going in between there? Less than.
Oh.
0.223 is less than 0.793 because of those tenths. Okay? That first digit, 2 is less than 7. Where decimals can get a little bit tricky, and actually this was a review on your last test, your pre-algebra review, or Math 6 review, and you did pretty well. Where they can get tricky is something like this, right? Because your brain wants to like see 27 and see 3, and think that, oh, 27 is bigger than 3, so 0.27 is greater than 0.3. What's the problem with that, Layla? Yeah, so I like what's called the stacking method, where if you stack your decimals vertically, okay, and you notice that 0.27 goes out one number further, what can we put here, and Layla said it, what can we put there that's not going to change the value of 0.3, but then put them out to the same number of places? 0. And when you do that, now you can see, oh, I'm not comparing 27 and 3, I'm comparing 27 and 30, right? And 27 is less than 30. What Melanie said, still just looking at the tenths, her method still holds. 2 is less than 3. It doesn't matter what comes after that, okay? So either way you slice it, this is going to be the less than symbol there. So that stacking method can be helpful. Anyone see any decimals here that are equal in value? Or you use that equal sign, Callie?
10.999, 10.9990.
Yeah, a 0 at the end of a decimal really means nothing. Okay? It's as if it isn't even there. Right? It can help us compare when we stack them, right? In the previous example, but it really doesn't have any value. So this would be an example of two decimals that are equal.
Wait,
Okay? Yeah.
couldn't the 2.54 and 2.540000?
That's another one that's equal. Okay? Because of those zeros there. What about 3.01 and 3.001? There's zeros in that one too. So equal?
No.
No, because the zeros are in the number, not after the number, right? So for this one, if you try the stacking method, 3.01 and 3.001, tack on a 0 at the end of the top one so they're all in the same number of places. We're really comparing 10 with just 1, right? Because the 3's are the same, the 0's are the same. Now we have this 1/100th compared to 0/100th, so this is going to be greater. Okay? The stacking method can really come in handy when you've got multiple decimals to order like you have in that bottom section there. Okay? If we look at this first one here, 0.884, 0.89, 0.879, and 0.0884. Our biggest, I shouldn't say biggest, our longest decimal goes out to the 10,000ths place, 4 places, which means we gotta add zeros on all of these to match it up. Okay? Now you look at this and you can compare, you know, kind of like 8,840 to 8,900 to 8,790 to just 884. And you can compare them like that. Like I said, on your test this went pretty well, but those that got this section wrong, I think if you would have tried the stacking method, it probably would have worked a little bit better for you. So, what is the smallest decimal here in the 4 that we have? Dominic?
0.0884.
Yes, 0.0884 is first. Then, anyway, you have your hand up for the last one, Candace. Answer this one. Which one comes?
0.879.
0.879. Then 0.884. And finally, 0.89. So, decimals, a little bit more complicated than integers perhaps, but that stacking method is really, really handy. Okay? And now we come to the entree, because fractions are just that thing that a lot of people just kind of struggle with. Okay? There's some discomfort, okay, with fractions. And so the thing that I want to point out to you, the biggest mistakes that I see folks make, right here, when comparing fractions, you cannot just look at how far away the numbers are. Okay? If you think of a fraction as a test score, and you just got tests back today, right? Your score, they're all in a fraction form. Both of these fractions here are 3 away, right? 3 away. Does that mean that they're the same?
No.
No. If you get 2 out of 5 on a test versus 37 out of 40, which one are you taking home to your parents to show them?
37.
Which one's going to get lost in your locker? The 2 out of 5, right? They're going to see the light of day. Okay? So you cannot just look at how far away the numbers are, because it's an unreliable method. Sometimes it works, sometimes it doesn't. And the fact that sometimes it doesn't means you don't want to rely on it. Okay? Make sense? Good? Got that out of the way? All right. So, here we go. So if you can't look at how far away something is, what can we do? What are some strats that you have to compare fractions? You've used in the past, you like them, you trust them, Ava.
Well, isn't there one where you like multiply the denominators and then you multiply like, then you do the crisscross method?
Yeah, so you're thinking common denominators, right? If you get the denominators to be the same, then you can just look at the numerators. And you've done common denominators before because you need them to add or subtract fractions, right? So let's take 3/6 and 5/10. What is our common denominator with 6 and 10? And this is why we talked about least common multiples, right? What's the least common multiple of 6 and 10? That first number that if you count by 6s or count by 10s shows up in both.
Could it be 30?
30, okay? So how we get there is we have to multiply that 6 by 5 and the 3 by 5, and that gives us 15 30ths. To get there here, multiply the 10 by 3, the 5 by 3, that gives us 15 30ths. Well, looky there. What's true about the fractions 3/6 and 5/10? They're equal, okay? And we got that by looking at common denominators. What's another way that we could use for these fractions, other than common denominators? What if we simplify them? Right? What if instead of multiplying to get a common denominator, we divided to simplify them? If we divide by 3 and divide by 3, we get 1/2. If we divide by 5 and divide by 5, this is how we get greatest common factor, right? We get 1/2, we can see they're equal there too. Alright? So, a couple different strats there. 3/8 and 7/12. Could we use common denominators here? Yes, that always works. Okay? It's not always the most efficient, but it will always work. Can we simplify these here? Can you simplify 7/12?
No.
No. Or 3/8? No. Okay? So the third method I want to bring to your attention is, we already kind of talked about it. Think about these as a test score. Okay? What's better? 3 out of 8 or 7 out of 12?
7.
And if you answer, be prepared to explain why you said that. Because, I mean, if you're looking at how far away they are, they're both 5. 3 is 5 away from 8, 7 is 5 away from 12. They're not the same. So which test score is better, 3 out of 8 or 7 out of 12, and be prepared to defend? Callie,
7 out of 10.
why is that better?
Because like there's more like problems on the test, so the higher number is better. Where like 3 out of 8, you basically failed.
Sure. If you got 5 wrong on a test, the more questions there are, the better your grade's going to be, right? A 1 out of 6 is very different than a 95 out of 100. Both 5 wrong with a 95 out of 100 is a much better score. How else can you defend that, Liam?
7 over 12 is 58%, and then 3 over 8 is 37%.
And how'd you come up with that? What'd you do?
I did 7 divided by, or 12 and 3.
Yeah. So you could take 7 divided by 12 and 3 divided by 8, because remember that fraction is just division, right? And then compare decimal values. What'd you say, 0.37 versus 0.57, something like that?
Yeah.
Okay, that's another way. Unfortunately, on this part of the test, you won't be able to use a calculator, okay? But that is another way. Is there a third? So think about the score 3 out of 8. Is that above or below half? Below, right? If you got half the questions right, you've gotten 4 out of 8. You got 3 out of 8, so this is less than 1/2. How about 7/12? Greater than half or less than a half? Greater. 6 out of 12 would be exactly half. You got 7, so this is greater than half. And any value that's less than a half versus something that's greater than a half, we know this is going to be less than. Okay? I'm giving you lots of different tools because the more tools you have in your toolbox, the better prepared you are for whatever the situation is. 5/11ths and 14/33. What method is going to be, I won't say easiest, but what method will be the most efficient here? If we think about a test score, 5 out of 11, 14 out of 33, I can't really quite tell. Can't simplify either of them. What would you do here? Just based on what the numbers are.
Would you multiply 5 11s by 3?
Yeah, I know that 11 goes into 30. So to get common denominators here, I'm really only multiplying one fraction. I don't have to touch that one, right? Because multiplying 5 11ths by 3 over 3 gives me 15 33rds, which matches my 14 33rds as far as denominators go. And so what symbols going in between those?
Greater than?
Greater than. Okay? How about the next one? 9/5 and 7/3. Improper fractions. Give me some strats for that. How are you going to figure out what symbol goes in between those? 9/5, 7/3. Kelly.
Can you multiply the fractions again?
So we could go with common denominators, certainly. What else? Sorry? Could do a test score. 9 out of 5 is really good. Some extra credit there. 7 out of 3, also good. Extra credit there. Any others? Connor?
Didn't you just know that like 3 goes into 7 twice?
Yeah.
5 into
Yeah, since these are improper fractions, remember that means they could be written as mixed numbers. We have some holes here, right? How many times does 5 go into 9? Once. Does it go in there twice? No. So we know that this fraction is somewhere between 1 and 2. 1 hole and 2 holes. Somewhere between that. Okay? 3 goes into 7 twice. Does it go in there 3 times?
No.
No. So we know that this fraction is somewhere between 2 holes and 3 holes. And so if you're looking at a fraction that's between 1 and 2 versus something that's between 2 and 3, well, this one's going to be less because it has fewer holes. Right? So you could use that as a strat as well. Can you tell I'm trying to coin the phrase, there's a strat for that? I figure it'll go well on my merch. I don't know. What do you think? You're my marketing test group here. Good? You like it? There's a strat for that? Okay. Strat is short for strategy, by the way, for those that aren't in the Mario world. Strat. Yeah.
We should do a sculpture that says permanent.
Yes, all the things. All the things. Okay, your homework for tomorrow is to finish the objective, finish PO7. We did much of it together. You probably have a little more than half. Some fractions left to do, some decimals left to do, some integers left to do, and then you have kind of a combo platter down here at the bottom where you've got 4 fractions, 5 decimals, and then, oh boy, remember when we learned how to convert from fractions to decimals? You can use that here. Okay, it doesn't matter if you put them all in decimal form or all in fraction form, whichever you want to work with, but those mixed forms there, put them all in the same form, and then you can order them from least to greatest from that. So, questions, comments, concerns, complaints, compliments, congratulations, criticisms on this? The key here, make sure you are showing your work. Okay, whatever you do, even if it's put it into a calculator, which I don't recommend because you can't use a calculator on the test, on this part here. But if you do, show me what you're doing, right? When Liam said that's what he did for this one, you know, I wrote down 3 divided by 8 and 7 divided by 12, those decimal values there, okay? Show me what you're doing. If I ask you, where's your work, and you say, I use a calculator, you can still show me what you did. Okay? All right. You have 10 minutes to work today. My goodness. Yeah. You may. Ready for a gusto-filled outro? That's how you math.
Make sure to like and subscribe.